Hello students, and welcome you all again to this video lecture series on chapter mechanical testing of metals. In very first video of this series we have seen what is a destructive testing and what is non-destructive testing methods for testing the metals. Then we have seen the difference between the destructive and non-destructive testing methods. Then we have started the destructive testing methods. In that first we have seen the tensile testing method, and second method we have just started in last video, that is the impact test. What is the impact that we have seen in that video, and what is the importance of this impact test, that also we have seen in that video. Now in today's lecture we will see what are the two methods for testing the sample for the impact test. So most common methods for performing impact test are first Charpy test method and second is ISOT test method. These two tests are nearly similar tests, but just a small difference in their orientation of test sample, and few application of load differences are there. What are these differences, that we will see in subsequent videos. So first we will see the first test, that is a Charpy test. The Charpy impact test is also known as a Charpy V-notch test. It is a standardized test which determines the amount of energy absorbed by the material during the fracture, and this amount of energy absorbed during the fracture is nothing but the toughness. So with the help of this Charpy test we are going to find out the toughness of that sample material, as well as we are going to find out what amount of impact energy is there to break that specimen. So this method is widely applicable in the industry since it is a very easier method and easier to conduct and find out the result. That's why we are using this method in various industries. So what is the sample that we are taking for the Charpy test, that we will see now. In that diagram you can observe the test sample we have taken with the length of 55 mm and cross sectional area of 10 mm by 10 mm with the 2 mm deep V notch at the exactly center or middle of that test specimen. So that V notch is again having some specification, that is nothing but that V notch is made with the 45-degree angle, and 2 mm deep V notch is there, and having the base radius of 0.25 mm, that you can observe in that diagram. So the test sample taken for this Charpy test is having length 55 mm, cross sectional area 10 mm by 10 mm, and V notch exactly at the center with the 2 mm deep and 45-degree angle of that V notch, and base radius of 0.25 mm. Similarly, for Charpy test we can take U notch also. Whatever V notch they have prepared, it is this in the test sample. Similarly, we can prepare the U notch also. That U notch will have some specifications such as 5 mm deep, again 1 mm radius of that V notch. So in Charpy test we can use either V notch or U notch in the sample. Then generalized test procedure is as shown in this chart. Similar kind of procedure in last video also we have seen generalized procedure for impact testing. Same procedure will be there for ISOT as well as Charpy test. Test specimen with the 50 mm length, 10 mm by 10 mm cross section, and V notch is at exactly center with 2 mm deep and 45-degree angle and 0.25 mm base radius. Secondly, place that sample in the position. Now here that position for the specimen is set like a simply supported beam as shown in this diagram. So there will be two rest pieces will be there. On that rest pieces you are resting your specimen like a simply supported beam, and V notch will be opposing to the hammer. So whatever Charpy test machine will be there, in that machine you can observe in the diagram it is having one pendulum. To that pendulum at one of its end there will be hammer attached, and its opposite end will be connected to the pointer. and that hammer will hit that test specimen exactly in the opposite direction of notch. In that diagram also you can, or in that animation also you can observe that that hammer is impacting the test specimen in opposite direction of the V notch. So similarly, place the sample in position. Third step, record the initial reading. So initially whatever reading in that pointer, it is shown, it is showing the energy readings. So that initial energy will be shown in the uh, pointer, shown by the pointer in the scale. Initially you have to lift that hammer or pendulum at certain height, initially capital H, and record at that position the energy reading. After that, uh, pull the red handle and move that or release that hammer from distance capital H, so that that hammer will move and hit to your specimen and break that specimen, and after breaking that specimen that hammer will swing further also. So whatever that further it has swing, measure that height small h. So that two heights, initial height and final height after hitting, you have got. Record these readings, as well as that pointer will also show certain energy after hitting that specimen. So initial energy and final energy, both energy you have got from the readings pointer, from the pointer scale, as well as you have measured the heights h1, sorry, capital H and small h. This is the general procedure for carrying out this test. Here in this diagram also it is shown that initially that hammer has been lifted by a distance capital H, then after hitting the specimen it will move with this certain similar, not similar, certain smaller height, that is small h. And you can observe here that hammer is hitting to that sample in opposite direction of V notch. Whatever capital H height is there, to which initially we are raising the hammer, that is generally standard for Charpy test and standard for ISOT test also. So what is that height and what is that angle, that we'll see in next slide. So some calculations with this Charpy test, we are going to find out what is the impact energy required to hit that test specimen, to break that test specimen, and what is the amount of toughness that material is having. So these two things we are going to find out through this Charpy impact test. So initially the mass of that hammer is taken for Charpy test is 20.932 kg. This is the standard weight, sorry, standard mass of the hammer that has taken for the Charpy test. For ISOT test it is having certain different mass. Then drop height, that means initially we are lifting that hammer with certain capital H height, that height is equal to 1.457 meter. Or if you are not able to measure that height, just raise that hammer with the angle 140 degree, that 140 degree from vertical position in downward direction. From downward direction it will be 0 degree, from that you raise it by 140 degree angle. So after that there will be the potential energy, initial potential energy at capital H height. That initial potential energy you can find out is equal to mg capital H. It will be giving you, because all the readings are known to you now, mass is known for that hammer, height is known for that, because for Charpy we are raising that hammer at this much height only, and acceleration due to gravity is 9.81. If you put all the values it will get nearly 300 joules is the initial potential energy. So at that potential energy we are raising the hammer and then we are releasing it. So at that raised height, if you release that hammer, then what will be the impact energy? It will, or impact velocity, there should be the velocity, impact velocity, uh, impact velocity, not the energy, impact velocity. And you know the formula for velocity is equal to square root 2gh, square root of 2g capital H. So 2 into small g acceleration due to gravity is 2.81 into your height, capital H height is 1.457. If you put all the values, you will get that impact velocity as 5.346. So that is the impact velocity you are getting in meter per second, equal to 5.346 for the Charpy test. At that velocity it will hit to your specimen, and after hitting that specimen, that hammer will raise again at certain small h height. So during that hitting to specimen and breaking that specimen is getting some energy, and that energy required to fracture that metal, or energy absorbed by that metal before fracture or up to fracture, is nothing but a toughness. And that toughness we can find out by formula here. Toughness is equal to initial energy of the pendulum minus final or swing energy of the pendulum. So initial energy, we know that initial potential energy is equal to mgh, mg is capital H, minus final energy will be mg small h, final potential energy. So difference between these energies, you will get the energy absorbed by the material before fracture. So that energy absorbed before fracture is nothing but, or energy required to fracture the material is nothing but a toughness. So that toughness you can get from this Charpy test. So these are some calculation parts in which we have found the toughness and the impact velocity and the initial potential energy for the Charpy test. Just for Charpy test, remember that we are placing the test specimen in the simply supported manner. We are placing that specimen having the V notch in exactly opposite side of the hammer hit, and for in the calculation, mass of the hammer is 20.932 kg and drop height is 1.457, so that you will get the potential energy initial, and you will get the impact velocity initially. After that you will get the toughness with these calculations. So this is regarding the Charpy test for the impact, finding the impact test or impact velocity and toughness of the material. In next video we will see the isot test